Hello. So, today I got a really fun one for you. I'm really hyped about this. As you can probably tell, I got a lot of energy. I've been drinking a lot of caffeine. The thing I want to share with you right now is how to do integration with partial fractions. And this is really good if, say, you've tried use substitution, or maybe you have 1 over some really complicated thing, and you just don't see a derivative in the top, and there's nothing you can multiply through. Maybe you've tried to separate terms off, and you've tried integration by parts, but nothing's really working. Well, now we can use something called partial fractions. So I'm going to take a problem out of a textbook here. I'm going to go ahead and work through this. So the problem we have the integral, and we've got 11x plus 17 over, and we have this over the top of 2x squared plus 7x and minus 4. Well, what can we do with this? Well, there's a few things we can do that actually get kind of cool. And I've got dx over here. Well, yeah, as you can see looking at it, not much we can do with it with our other integration techniques. We have a rule, though, that says if we factor the bottom, a over the first part of the factor plus b over the second component of the factor will equal what's on the top. And if this was a third degree, then it would be a over the first segment, b over the second segment, c over the third segment, and then we'd have to solve for 3 arbitrary values on the top. But this is only going to have 2 because this is second degree. Now, one really important thing to keep in mind when you're using this technique, the bottom has to be a higher polynomial than the top. And think of this like a fraction. Well, we need a proper fraction, right? We don't want the top bigger than the bottom. So we'd have to put in that form. Now, say the top was a third degree polynomial. We could use long division of functions, but that's kind of a whole thing in itself, and I'm not going to put any more into this video on those lines, because this is going to be a long video anyway. So what do we do with this? Well, we got to factor the bottom first. Now, to do that, this is a kind of an icky one to factor. We can't just do it how we might normally think. But let's say we'll break it up a little bit. We're going to say 2x squared plus, and I'm actually going to put in an 8x. So I'm going to say minus x. We can get rid of that plus. Yeah, the ink is running. Cool. Okay, minus x. And now we're going to say plus 8x minus 4. And that's an equivalent form to this. We're going to stick some parentheses in here, and we're going to factor this kind of by grouping it. And now we're going to say, well, what do we got to do to make these two things in the parentheses equal? Well, we got a 2x, so let's pull out a 2x here. So we're going to have 2x, and that's going to give us x minus 1. And that's kind of an easy target, because look, if we divide these by 2, we're going to get 4. If we divide them by 4, well, we're going to get 2 and we're going to get 1. This should work. So then we're going to say we have plus. Let's pull out, let's take a 4. So we're going to take a 4 out, and we're going to say that gives us now x. Oops. Actually, I see a better way to do this. This is what happens when I don't prepare when I do a video. I just kind of do these off the top of my head. There's a better way here, though. We can just take out an x. So we're going to take out an x, and then we're going to have 2x minus 1. And we're trying to simplify this as much as we can, right? So that's going to be plus. Well, we can do the same thing here. We're going to take out a 4. But what's this going to do? And this is kind of cool. Well, now we're going to have a 2, because we have 4 times 2 is going to be 8. 2x, and minus, and then 4 divided by 4, that's going to be 1. Minus 1. So now we have the two terms in our parentheses equal, and we just start to add these terms up. So this, we're going to take those, and then these are going to cancel out, and we're only going to keep 1. So the first term here is going to be x plus 4. That's these. And then we're going to say that times what's in the parentheses, which is 2x minus 1. So that right there, that's our factored form of the bottom. So we can write this out, and we're going to say the top is equal to AB. So we're going to say A over, and I'm leaving out the integral because I think, it gets to be a little more than we need going on here. But we're going to say we have A over this first part, which is x plus 4. And this is going to be added to, and we're going to put in B as some arbitrary thing. We're going to have B, and we're going to take the second term. So we're going to have 2x minus 1. And that is all going to equal what's on the top. So that's all going to equal 11x plus 17. So we're getting somewhere. But now we got these arbitrary values up top. And they don't really fit into our equation at all. Well, they fit in our equation, but they don't work in our integral. So we're going to have to solve what's A. We're going to have to solve what's B. So we're going to do this using a little bit of a linear algebra technique. And there's a few ways we can do this, but I'm going to show what I personally think is the simplest way. And everyone has their own method of doing it. But think about what we got to do. Well, if we're going to add these terms, we need to have a common denominator. And that common denominator is going to be x plus 4 times 2x minus 1. So to do that, we're going to multiply this side by 2x minus 1 over 2x minus 1, and we're going to multiply that side by x plus 4 over x plus 4, which is a version of 1 over 1. I'm going to skip kind of the example of that, and I'm just going to cross multiply it. So we're going to say a times that plus b times that. So we're going to have a times here, which is 2x minus 1. And we're going to say that added to the other way, which is going to be b times x plus 4. And that is all going to then equal our equation over here. Equals 11x plus 17. Kind of running out of room over there, but I hope you guys can see it. Now look at that. We're getting somewhere. Again. But we now have A terms and B terms, and we have X terms, and there's all this stuff going on. So we need to actually eliminate something. We can't solve for all three variables at the same time. And to do this, we're going to now multiply through everything. So we're going to get, well, A times 2x. I'm going to write this a little differently. I'm going to write this as being 2xa, and that's that. And we're going to multiply A by 1, so we're going to get minus A plus b times x is going to be bx plus b times 4 is going to be 4b, and then that's going to all equal 11x plus 17. Probably shouldn't be drinking any more caffeine right now. That didn't happen. So now what do we got to do? Well, we need to group all of our A terms, and we need to group all of our B terms, and we need to group our X terms, and get everything together. So we're going to pick our B's and our A's. So let's put X's on the top, and let's put B's on the bottom. Let's take 2x A, so there's our A, minus bx, and this is going to be our other x term. So we have bx, and that is going to equal our x component of our answer. So that's going to equal 11x. And this, for me, is very simple, and I think in some ways it kind of is hard to explain. You really just have to play with this and kind of get it ingrained to understand it. But then the other component we have a non-x term. So we have A plus 4B equals, and that's going to equal our non-x term in the answer. So that's going to equal 17. Now, what we're going to do is we're going to try and eliminate A, or we're going to try and eliminate B. Then we're only going to have one thing to solve for. So we're going to do plus. And let's see, I got to check the time because I actually have a class after this. We good, but I got 5 minutes to finish it. So, well, what can we do? Well, look at this. we have common terms we can get rid of. We have an x right there, we have an x right there, we have an x right there. So if we divide on both sides of the equal sign, which we can do, because it's, you know, we can do things if we do it to both sides, we can eliminate that x. So we're going to say the x goes away over there, the x goes away right there, and the x goes away right there. Now what else can we do? Well, we need to get rid of, let's get rid of a first. Let's look at, well, we have 2a. I'm going to move this over so it's a little bit more clear. We have a plus. We have 2a and we have 2b. We want to get rid of one of those. Well, what can we do? Well, let's say we multiply this by 2. Because then we're going to get, oh, this should be a negative. Oh, that's a biggie. Hopefully you see that because we had a minus a plus, and that carries down to here. That's a big mistake. You want to make sure you catch these things. Don't do what I did. So if we multiply the bottom by 2, well, we're going to get 2a, we're going to get 8b, and we're going to get equals 17 is going to be 34. So I'm going to go ahead and write all this up here again. We're going to get 2a plus b equals 11. And now we have negative a times 2, which is going to be negative 2a, plus 4b times 2, which is going to be 8b, equals, and then we're going to have 17 times 2, which is 34. 34. And we're going to put our addition back, plus. Well, what happens when we add 2a to negative 2a? Well, it goes away. So that whole term goes away. Now all we have is we have b plus 8b. Well, that's 9b. So we have 9b equals, what's 34 plus 11? Well, it's 45. So we have 45. See where we're going with this? Hee hee, I love this. Okay. Now, we're going to divide both sides off by 9, so we're going to divide that by 9. We're going to divide 40 by 9. Well, we have 9, 18, 27, 36, 45. 5. So b equals 5. B equals 5. Now we have 1. Now let's take one of our terms. So let's take our chunk here. I'm going to do this in a green pen. Let's take our a, negative a, plus 8, oops, that was a 4, plus 4b equals 17. Now remember, that was this before we multiplied it by 2. So it's just, and you could pick either equation. You're just picking one of the equations and you're going to solve it. And now we're going to solve this for b equals 5. So now we have negative a plus 4 times 5 equals 17. That's going to give us negative a plus 20 equals 17. And now we can divide things off. So we're going to say negative a is going to equal, and we're going to say, well, 20 minus 20, and we're going to say 17 minus 20. And 17 minus 20, well, that's going to be negative 3. So we have equals negative 3. So negative, negative are, so if we have negative a equals negative 3, we're just going to multiply both sides by negative 1, and that's going to give us a equals 3. Okay. So we have a equals 3. Now, we're just going to plug all these things right smack back into our equation. So we have the integral, and we're not going to use this. We're going to use our a over first factor plus b over second component of the factor. So we have a over, and I think we had x plus 4, and we plus b over to 2x minus 1. Yeah, that was it. Dx. And then we're going to plug in for a. So a, well, a is 5. And b, well, b is 3. B is 3. That looks like something that we know how to solve. So we're going to use natural log with the integral. We're going to break this into 2 halves first. So we're going to say we have the integral, and I'm going to pull out the 5 because that's a constant. We can do that. So we're going to have 5. We're going to have 1 over x plus 4 plus, and we're going to pull out the constant 3 integral of 1 over 2x minus 1. And I left out the dx. I know it's kind of a bad habit to leave things out of the signs, but I don't know, I'll remember it. And that's a piece of cake. What's 1 over something when we take the integral? What's natural log? So this whole thing is just going to simplify down to 5. I'm going to just do this. Natural log of x plus 4 plus 3 natural log x minus 1. I changed my symbols around right there a little bit. But, what are our rules of exponents? Well, if we have 5 times natural log, we could also just say that this is natural log of x plus 4 to the 5th. And then we could say that that's plus 3 natural log of x minus 1 to the 3rd. And then obviously plus our c, but there's no reason to do that. We don't have to simplify it. This is a perfectly good answer, and in most classes you're probably going to take, you're going to be left, asked to leave it like that. So from that, we can say that this equals this. So we're going to have 5 natural log of x plus 4 plus, plus 3 natural log of x minus 1 plus c. And that plus c is just some arbitrary constant. We don't know what it is. It doesn't matter. I hope you found that helpful. This is a long video. It's kind of hard to walk through these step by step. I wanted to give as much content as I could, but if you have any questions, you want me to solve anything in the future, send me a message or something, and I'll do my best to explain them as well as I can. So I hope you have a good day, and see you next time.